Alright, 12, writing the expression in simplest exponential form. First glance, once again, it might be very easy to get really stumped on these problems, and the reason why some students get stumped on the problem is because they're looking at the fact that you're trying to take a cube root and divide it by an eighth root. But the fact of the matter is that these are not simplified. So, what you have to remember is that because we have a cubed root of x to the fourth and an eighth root of x to the fourth, we could rewrite these guys because the roots are underground. So a real rewrite of each one of these as rational exponents, we'd end up with x to the 4/3 power divided by x to the 4/8 power. Okay, and then a little bit of review that we're going to need here, right? When the roots don't match, we can change them to rational exponents, which is what we just did, and then we subtract the exponents. Now the problem with subtracting these two exponents, 4/3 minus 4/8, is that we do not have a common denominator. So once again, we need a common denominator here between a 3 and an 8. Wouldn't that be 24, I believe? Or, oh wait, you know what I did do actually here, that might make things a little bit easier, is I reduced the 4/8 out of 1 to 1/2. That can work, because then our common denominator would be 6, right? So if we make each one of these fractions have a common denominator of 6, the equivalent fraction to 4/3 using 6th, and the equivalent fraction to 1/2 using 6th would be 8/6 and 3/6 respectively. So now I can take 8/6 and subtract 3/6, and then that would end up with 5/6. And be prepared to write either one, okay? If the answer is multiple choice, and you see answer choices look like rational exponents there, know that that's got to be the case. Or, who knows, you might see a problem where the multiple choice answers are written with the roots underground with 6th root of x to the 5th. If it's short answer on the test, I'll accept either one of these. I don't care which way you write it. So I would imagine that many of you are probably, if it's short answer, you're probably going to leave it like that, and that's totally cool with me. Okay? B, absolutely no different. I covered that one up. You can definitely check that answer later. Alright, so let's take a look at number 13. Still, roots are underground. My dog is barking again. I think he sees a squirrel this time. Squirrels are always trying to get up in his business. Alright, so anyway, negative 32 to the 2/5 power. Simplify each expression. Notice what I put right here, and I'm going to put this on the test too. I'm going to make you show your work by rewriting it as a radical expression. What does that mean? It means I want to see you take that fraction, understand that roots are underground, and be able to rewrite this guy as the 5th root of negative 32 squared. Now there's two different ways you could have written this. You could have written it like that, and I suppose you could have written it like this. The 5th root, let me get this right, negative 32 parentheses squared. Okay? Either one of these are equivalent. Okay? And it really doesn't matter which way you do it. You're going to get the same answer no matter what. Why would I prefer red versus green? The only reason why I prefer red to green here in this case is just for the fact that I can take the 5th root of negative 32 in my head. I know what that answer is, and it's got to be not positive 2, but negative 2. And so ultimately what I'm doing is negative 2 squared. Now, negative 32 squared, I could probably do that in my head, eventually get an answer, but what I would not be able to do in my head very easily is take the 5th root of that really large number. But what I can do in my head very easily is take the 5th root of negative 32, knock it down to negative 2, and then square negative 2 to give us an answer of, you guessed it, positive 4. Okay? So that's kind of the one suggestion I would put on you there is, I would probably highly suggest, and I will just uncover this part right here, is I would suggest doing the root first. That way you can do one of two things. Either do it mentally like I just did, the 5th root of negative 32 is negative 2, or you can use your calculator. Is it against the rules for you to show this work? Because I'm going to require you to show the work. To show the work, jump through that Mr. Cook hoop and write this right here in red, and then go right back to your calculator and just type in the problem, for example, go back to letter A. Could you jump through the hoop, write that there in red, but then go back and just do, I don't know, negative 32, close the parentheses, raise it, important to use parentheses here, and wasn't it 2/5 power? Great way to check your answer too, isn't it? Oh look, 4. So do you see what I'm talking about here is that you can use your graphing calculators to check your answer. You can use your graphing calculator after you do that work to actually finish the problem. Okay, that works just fine. Alright, so 14 and 15 are now getting you to solve radical equations. We're going to keep it pretty light here. However, 15 can be a little bit heavier than number 14. But what you have to always keep in mind when it comes to this, when you watch that video, when we did do section, which one was that? 5. It's very, very important that we have to isolate either the radical, like we're going to do here on number 14, or isolate the exponent, like we have to do on number 15. And you're in luck. This time I'm going to do both here in this video. Okay? So, the first move that we have to do to isolate that radical on number 14 is we have to subtract 3 because it's a positive 3, right? So subtracting 3 from both sides, we end up right about here, right? The square root of x minus 9 is equal to 5. Now that we have this isolated, now to undo the square root of x minus 9, remember what we can't do? We can't add 9 to both sides. Do not add 9 to both sides right now because it's protected by that square root. You have to undo that square root first. Okay? So to undo that square root first, we have to square both sides. And so that's exactly what we're doing right here. The square will undo and be the inverse operation of the square root, and then we can square the other side there of that 5, and we'd end up with a statement of x minus 9 equals 25. This is a pretty simple problem to solve because now all I have to do is add 9 to both sides, and then we get 34. It's very, very important to check your work on these problems that involve radicals. So here's us checking our work. We took the original problem, 3 plus the square root of x minus 9 equals 8. We substitute 34 in there. 34 minus 9 is what we have to do first, right? And we're in luck. 34 minus 9 gives us the perfect square of 25. We got to square root that 25, which gives us 5. 3 plus 5, hey look, we get ocho on one side and ocho on the other side. We got it. Okay? So let's take a look at this other problem here. The reason why I want to deal with this problem here, it's a rational exponent, a little bit different when it's a radical versus an exponent, but here's what won't change. What won't change is you still have to isolate. You still have to isolate the exponent. So the exponent that we have right here is this guy right there. That's it. So to get rid of that, see what's outside there is that 2. We're going to divide both sides by 2. And when we divide both sides by 2, we have x minus 1 to the 3/4 power equals 8. So here comes the cool move. Now that we have it isolated, we're going to raise both sides to the reciprocal power, which in this case, the reciprocal of 3/4 would be 4/3. Okay? So, since we have 4/3 here, here's how that would look. We can take x minus 1 to the 3/4, raise it to the 4/3, and we're going to take 8, raise that to the 4/3. Okay? Now, here's the good news. When you raise something to the reciprocal power, we are going to get 1, right? So over here, we get x minus 1 to the first power, which is going to be x minus 1. Over here, 8 to the 4/3 power, I would recommend you just type that into a calculator. Use parentheses when you put that into your calculator, and it should burp out as 16. Now here's the good news. Since the denominator that we're dealing with right here is 3, which means we would be taking a cubed root of 8, and the cube root of 8 would be 2. There's only one root there. Think back to question number 1a. Because it's an odd root, there's only one real root to it. So we don't have to worry about any plus minuses here. So the cube root of 8 would be 2, and then take 2 to the 4th power, which would give us 16. Okay? And so then we can solve this problem by adding 1 to both sides, and so then we get x to being 17. We can check that 17 into the original problem. The original problem was way up here. 2 times x minus 1 raised to the 3/4 should be equal to 16. See how I substitute 17 in there? 17 minus 1 gives us 16. Now order of operations dictates that we have to take 16 and raise to the 3/4 power first. Okay, a fourth root of 16, I think that's 2, and then we got to cube that 2, which would take us to an 8, and now we have 2 times 8, don't we? And 2 times 8, is that equal to 16? Yes, sir, it is. That's kind of what I wrote right over here eventually. There it is. So 16 equals 16. Okay? So that's how these problems work. Just to sum this up one more time. And then we'll close this video and move on to another video part. Isolate the radical first. Sometimes you have to do a little bit of algebra first. And then once you do that, if it's a radical, raise it to that same power. If this was a cube root, you'd cube both sides. Okay? If it's a square root like this case is, wink wink, nudge nudge, test test, square both sides. And if it's a rational exponent, raise it to the reciprocal power.